Look at a map, find the cold heart of Canada, and you will hit Calgary. Here, winter falls heavy. The ground freezes solid and stays locked under snow and ice for months. Now, track your finger straight east across the Atlantic Ocean, keeping to that exact same line of latitude. By the basic rules of planetary climate, whatever sits on the far shore should be gripped by that exact same deep freeze. Instead, you find London. In January, you can walk through the city in a light coat, catching rain instead of ice, passing gardens that stay green straight through the winter. This breaks the simplest law we have about the planet's climate. Latitude dictates how much direct sunlight a place receives, and sunlight dictates temperature. The closer you are to the poles, the colder you get. This map tracks temperature anomalies across the Atlantic, showing a massive gap. It plots Madrid running warmer than New York City in the dead of winter, even though the Spanish capital sits hundreds of miles further north. It shows Vienna staying above freezing, while Grand Forks, North Dakota, plunges far below. Entire regions of Europe sit up to 15 degrees Fahrenheit warmer than they should. That gap is an active process. Europe is kept out of the deep freeze by a massive, specific machine running silently in the background. For centuries, the textbook explanation was the Gulf Stream. Warm water gathers heat in the tropics, peels away from Florida, and crosses the ocean like a central heating pipe. But that visible river of warm surface water is only a fraction of the system. It sits on top of a much deeper, slower, vertically integrated loop. Scientists call it the Atlantic Meridional Overturning Circulation. Think of it as a conveyor belt standing on its end. Warm, salty surface water flows north toward Greenland, gives up its heat to the cold sky, grows dense, and sinks thousands of meters down before sliding back south. This loop shoves 30 billion kilograms of water north every second. It transports roughly 1.2 petawatts of heat toward the northern hemisphere. That is the energy equivalent of 1 million power plants running at full capacity, constantly pumping warmth toward the pole. Yet, when researchers measured how much of Europe's mild climate actually comes from this specific current, they found it explains at best half of the temperature gap. Moving all that tropical heat north into the Atlantic is useless unless something can physically pull that warmth off the water and push it deep inland over the continent. Water is incredibly slow to change its temperature. All summer long, the North Atlantic absorbs sunlight, acting as a massive thermal battery. Then, through the dark winter months, it slowly breathes that stored heat back out into the air. Europe sits perfectly downwind of this giant radiator. The prevailing winds in this region, called the westerlies, blow from west to east. They sweep across the Atlantic, pick up the stored summer heat, and push it directly over northern Europe like a fan blowing across a heater. North America gets no such benefit. Those exact same westerly winds blow its weather off the frozen continental interior and out to sea, pushing the cold away from the land. But there is one more geographic mechanism driving this airflow, and it sits thousands of miles away on an entirely different continent. The Rocky Mountains form a massive physical wall running north to south, standing directly in the path of the upper atmosphere. When those high-altitude westerlies slam into that towering wall of rock, they are forced to compress and bend. This collision generates massive stationary waves that ripple out and snake all the way around the northern hemisphere. Those planetary waves set up a specific persistent pattern. They force cold Arctic air down over eastern North America, and they pull warm air up over the eastern Atlantic and western Europe. London is not milder than Calgary because of a single ocean current. It is kept warm by an exact alignment, a vertical ocean conveyor, the sea's thermal memory, steady westerly winds, and the physical shadow cast by a distant mountain range. Every piece of that machinery depends on one crucial physical trigger, the moment in the far north when the salty surface water becomes dense enough to sink. As the planet warms, the massive ice sheet covering Greenland is melting, pouring thousands of tons of fresh water directly into this precise sinking zone. Fresh water is lighter than salt water. It floats. This rapid influx of fresh meltwater creates a buoyant lid on the surface, acting as a physical brake on the ocean conveyor belt. This heat map shows almost the entire planet glowing with warm temperature anomalies. But right beneath Greenland sits a stark, cooling patch of water scientists call the cold blob. It sits exactly where the sinking action should be, drawing down warm water from the south. A stubbornly cold spot in a warming ocean is the exact physical symptom you would expect to see if the engine were beginning to stall. If that circulation collapses, a warming planet would ironically plunge modern European cities into historic freezes. Recent models suggest a total shutdown could drop London winters down near -4 degrees Fahrenheit, while extremes in Oslo could plummet toward 50 below zero. The stakes reach far beyond Europe. This ocean loop helps set global rainfall patterns. A weakened conveyor could shift tropical rain belts thousands of miles, scrambling monsoons and drying out farmlands that billions of people depend on for food. We know this machine can break, because the Earth has run the experiment before. At the end of the last ice age, a massive pulse of fresh glacial meltwater flooded the North Atlantic and stalled this exact current, dropping the Northern Hemisphere into a deep, brutal freeze that locked in within one human lifetime. The mild climates allowing massive cities to rise in the far north were never a guarantee. They are the output of a delicate, moving balance, and for the first time, humanity has its hand on the dial.